So, hello everyone. I'm Tathagata Dey, All India Rank 21 in GATE Computer Science 2022. And today, in this first session, we're going to see the Theory of Computation questions of GATE 2022 paper. And this is the first session I am ever taking, so I'm a bit nervous. But anyways, we have to get going. So, let us just begin with the session. Here we have the first question. Which of the following regular expressions correctly represents the language of the finite automaton? So this is the question, and this was a 1 mark question in GATE 2022 paper, and 1 mark MCQ of course. And we're gonna solve this question. Um, okay, I'm just changing the color. Okay, so this is the NFA given. This is NFA definitely, as you can see, because there are choices, different choices, and so you see here this is a transition for the input B, and this is another transition for the input B from the same state. So definitely this is an NFA, and let us see the options. Okay, the first one, we don't need to consider the both of the parts. Let us just take the first one. See, this problem can be even solved with Arden's theorem, but solving the problem with Arden's theorem, I guess, is should not be done in competitive exam, because the time and the accuracy both are important, and solving the question in Arden's theorem may take 3 or 4 minutes. So I guess this can be drawn more intuitively. So let us just see. Let me take the first part. Okay, A B star B A B star. This is the part. Okay, so this means first this is A B star B. So this goes as A and then B star. Okay, this is the loop, and then comes with B in the initial state again, and then again goes A B star. So we'll go again A and again B in this loop. So this is the part. Okay, but it is limited times that we are this loop is forming just one time, and we want it unlimited number of times definitely. Let us just take one example to see it clearly, that the counter example that I am talking about should be um, a b a b a. Okay, so this should be the counter example. You see, when we are talking about A, it goes here, and then B, and after that again comes A. So we cannot take this loop, we have to go back here. So this is B, this is A, and then again A B. So again it goes A, and again it comes B, and then again it goes A. So this is the string. This should be accepted by the NFA. But can we generate this from the regular expression? No. See, this A comes. We cannot take this B star, because this B has to come from here. This A has to come from here, and then this B can come from here, but no place for this A. So definitely this is not generated by the regular expression, and this is the wrong option. Another reason we are taking this part for the second option, say A B star B whole star A B star. Okay. Let me just clear this up. This maze should be cleared for the better understanding. Okay, yeah, so we're done. Okay, so this is the option, and say A B star B. So A B star B, this loop has been given with a clean closure, so definitely we can generate many number of times, unlimited number of times. But and it ends with A B star. So from the initial state it again goes A and B star, this part only. But what about when from the initial state, after completing this loop number of times, we want to come this side, that is B A star? What about that? These strings should also be accepted, right? So let me take an example. Okay, um, okay, the example should be A B B A A. Okay, this is example. Say A, so it goes here, and then B B. So and after two B's we have A again. Yeah, so this B, we say that this B, first B can come here. So this is A, this is B, then again goes here B and A. So this string is accepted by the NFA. Can we generate from the regular expression? No. See, this A comes from here, and as you know, they say this B comes from here and this B comes from here, and I have taken the loop just one time just to show the counter example. Okay, so this A has to come from here, so we have to end this loop. Okay, because this A cannot be only be generated by the outside A, because this A has to follow by this B, and we don't have B after this A. So this A is generated from here, but no place for this A. So again, this cannot be generated from this option. So this is also wrong. See, option C is very intuitive and very easy. We see that this has a clean closure, and these are also having clean closures. So epsilon is generated from this regular expression, but can epsilon be accepted by this NFA? No. The answer is so. Definitely, this is also the wrong option. And let me clear this mess. Okay. Yeah. So and the left option is this is indeed the right option. Let me just say B A star A, so it comes here, B A star A, it goes there, and the another loop is A B star B, A B star B. These both are both loops are uh, um, having in the regular expression, and they are added with clean closure. Definitely we can do it any number of times, and it ends with A B star or B A star. So we can choose any one of them. What is that? Because we are, after completing a loop, we are in the initial state, and we can go A B star, that is we complete here, and B A star, that is we complete here. So anything we can do, say we take A B star B a number of times and then choose B A star. So we go A B star B and then B A star. We can end up here. So this is accepted. This is very much valid, which I explained in the previous slide. So in this way, we can say that this is the right option. Option D should be the right option. So yeah, we are done with this. Let us go to the next question. Okay. So yeah, this is. So this was another 1 mark question of this year's gate paper, and let's see what it says. Which of the following statements is or are true? So it can be MSQ too. Actually, I guess it was MSQ. Let's see. Every subset of a recursively enumerable language is recursive. So as we know that, say this is recursively enumerable language, and this is recursive language. So a set is a subset of itself, right? We can say that A is a subset of A. Now we assume that a language is here, L. Say L belongs to REL but not REC, and L is a subset of L, and so definitely L, say every subset of a recursively enumerable language is recursive. Yeah, so L is a subset of L, so this is a recursively enumerable language, and this is definitely not recursive. So the statement is false. It is very intuitively easy, I guess. So yeah, this is a false statement. Let us go to the next one. If a language, let me just change the color. I'm so obsessed with colors. Anyways, if a language L and its complement L complement are both recursively enumerable, then L must be recursive. Okay, so the concept is that, say this is the idea, say there is a language L1, then L1 complement will belong here, and if there is a language L2 here, then L2 complement will belong here. Okay, let me write here the concepts. Okay, one, if L belongs to REC, implies that L complement will also belong to REC, and the second one says that if L belongs to REL but not REC, implies that L complement will belong to not REL. Okay, this is, you know that this is the others languages of 2 power sigma star. Okay, so this is the concept, and we are using this pretty evidently, that it says if a language L and its complement L complement both belong to recursive enumerable, that both is inside this. So where can it be? Of course here. So then L must be recursive. Yeah, this is evidently, of course it has to be true. Next one, complement of a context free language must be recursive. Okay, let me see here. We are drawing the Chomsky hierarchy again. Say this is a context free language. Outside this goes a CSL, that is context sensitive language, and outside this is the set of recursive languages. And we know that CFL is not closed under, what does it say, complement. So definitely it can be anywhere like here, but here, but yeah, see CSL is closed. So definitely it will be belong to here in this section, and this is under recursive. So this is a subset of recursive. Yeah, this is true. This has to be true again. And the last one, if L1 and L2 are regular, then L1 intersection L2 must be deterministically context free. Let me draw the Chomsky hierarchy of that part again. Say this is regular, and regular set of regular languages is a subset of set of DCF, that is deterministic context free languages. So let me say L1 and L2 belong here. So if L1 L2 belongs to regular language, implies that L1 intersection L2 will belong to regular language by, we know that, closure property. So L1 intersection L2 belongs to regular language, and this is a subset of DCFL, right? So yeah, this has to be true. So the answer stands as B, C, D is the answer. And if you have opted this, so you will get +1 mark. Okay, so let us come to the next one. This is one of my most favorite problems. Like when I found this question on the paper, I was so intrigued. I mean, really, I love this question. Let me just say why. This was another 2-mark question, another MSQ. Okay, so the intuition part comes in a great picture here. Say let's just consider L1. Okay, say L1 equals to AN W AN. There is no comma or anything. Okay, so how any string, say a string W belongs to L1, how W is decided? We won't take W because W is already here, so we will take any string, say S belongs to L1. So how S is decided? S is decided on 2 factors, that is value of N and W. Yes, definitely. So N and W will take that. See, W belongs to what? Sigma star. So N and W will take different values. There will be a case when see we know the string that epsilon belongs to sigma star. This is epsilon, right? And this belongs to sigma star. So there will be a case when we will put that W equals to epsilon. Let us just try that case. So it becomes N A N A N, and N can take any value, that N belongs to say natural numbers. So for N equals to say 1, it is A. For N equals to 2, it is A, and so on. So what is this? This is set of even number of A's. That is, let me just say, yeah. So this L1 will contain epsilon. If n there is no constraint, we don't know if n equals to 0 or not, but that won't matter because in any case it is regular language. Say a to the power 4, a to the power 6, a to the power 8, and dot, dot, dot. So it is a regular language. L1 belongs to regular language. This is the most important part. We have derived this by intuition. So in the same way we can do for L2. For L2, it says Wx, Wr, where W and X both belong to sigma star. So we will put here. I will put sigma W equals to sigma. So L2 will have only X, where X belongs to sigma star. So what is L2? L2 equals to sigma star. L2 does contain all the strings. So definitely L2 is also regular language. So if L1 and L2 both are regular language, yes, this is true. L1 and L2 context free, yes, this is also true. We know by, okay, hang on a second. We know by, yeah. So we know by that this is, if this is regular, then this is CFL by Chomsky hierarchy. So yeah, this is true. If L1 is regular, L2 is context free. This is also true. L1 can be here and L2 is also here. Both are them CFL. So yeah, this is also true. So, and the last one, L1 and L2 are context free but not regular. So context free but not regular means in this section they do not belong here. So this option is incorrect. Answer should be A, B, and C. This was a brilliant question, as I feel. If you have any doubt or those proofs, if you require them, please do let us know in the comment section, and we will definitely try to do that in separate lectures, of course. And this is the first session that I ever took, so if in case of any mistakes on my part, please do forgive me. I will try to make it better, and together me and Akash will work very hard on this because we have something to provide, I believe. And thank you very much. If you have watched this, I appreciate this. And also do let us know any questions, any doubt that you ever came upon, or you just facing right now. Just let us know in the comment sections or mail us. We are providing our own LinkedIn profiles and everything. Just let us know anywhere. We'll try our best to provide all as much of possible of them. So wrapping up for this video, I guess. Thank you very much for joining.